All right, let's go over today's Check Your Understanding. So Sharon claims that 90% of students can identify the smell of a skunk. She carries out a study to test this theory. She selects a random sample of 100 students and asks them each to take a whiff from a bag that is filled with skunk smell. She finds that 84 are able to correctly identify the smell as that of a skunk. She would like to know if these data provide convincing evidence that less than 90% of students can identify the smell of a skunk. Use alpha equals 0.05. So convincing evidence, that tells me I should be doing a significance test. Okay. State appropriate hypotheses for performing a significance test. Be sure to define the parameter of interest. Okay. So first I need to look at my claim. So my claim is 90%. And we're really looking for our parameter being how many people can identify that of a skunk. So my H naught, okay, is that the proportion is equal to the claim of 0.90. And then my alternate hypothesis, she thinks that less than 90%. So P, the true proportion, is less than 0.90, okay? And so what is P? We have to identify that. That's our parameter of interest, what we're trying to estimate. Okay, and we can say that this is, P is the true proportion of students who can identify the smell of a skunk. All right, so part B says, explain why the sample results give some evidence for the alternate hypothesis. Okay, well, our sample result was our P hat, or is our P hat, and our sample said that 84 out of 100 people could identify, so 0.84, which is less than our claim. Okay, so that's some evidence. Okay, our sample resulted in less. Part C, check if the conditions for performing the significance test are met. So remember, we have 3 conditions to check. Okay, we have our random. And in the problem, it says that we have a random sample of 100 students. So we've met that condition. Our next condition is the 10% condition, which says that our sample size, 100, has to be less than 1/10 of all students, which definitely fits. And then our last condition that we have to check is our normal condition. And in this case, we're going to use our large counts condition, which says our sample size 100 times our claim 0.90 equal to 90, which is greater than or equal to 10. And 1 minus P, so N 100 times 0.10 equals 10, which is greater than or equal to 10. So we have met the large counts condition. We can use an approximately normal curve, which is good because in part D, we need to calculate the standardized test statistic. So what have we learned? We know that we have a normal distribution with a mean of 0.90. Okay. And if we calculated the standard error square root of P times 1 minus P divided by N, we would get 0.03 as our standard deviation. And I'm looking for, in my sample, I got a sample result of 0.84. And I want to know the probability of getting that or less, because in my alternate hypothesis up here, I'm looking for P is less than that value. So if we're finding a Z-score, Z equals sample proportion minus the true proportion divided by the standard deviation, P times 1 minus P divided by N. Okay. So we could plug in the numbers there. We've got Z would be equal to 0.84 minus 0.9 divided by that 0.03. And you should get the value -2. Okay, this is my Z-score. So then going to table A, we get 0.0228. Okay, now this would be one of those instances where it might be faster to use the normal CDF function in your calculator to calculate that. So your lower bound would be like -10,000. Your upper bound would be the 0.84. And then your mean and your standard deviation. Okay, so here's our p-value, 0.0228. Okay. In part E, we want to know what conclusion should Sharon make. So we're looking at that. We're comparing to 0.05 because in the problem it says use alpha equals 0.05. So because 0.0228 is less than 0.05, we have convincing evidence that less than 90% of students can identify the smell of a skunk. Okay, so because our p-value is very low, that result of 0.84 is very unlikely to happen purely by chance, which says that our claim of 90% is probably not true. Okay, so we have convincing evidence that it's less than 90%. Okay, I promise these get faster and easier the more of them that you do. If you have questions still, make sure you're asking in class.